In the last lesson, we learned dimensional analysis, where we treated the dimensions of physical quantities like algebraic quantities to check whether equations made sense. Today, we're going to use that exact same reasoning to do something absolutely essential in physics, which are unit conversions. Now, before we even get into this, unit conversions are not about memorizing tricks or memorizing numbers. What it really is just dimensional analysis with numbers attached to it. So today we're going to build a simple system that guarantees you're going to get it right every single time. Now, before in the last lesson, we saw that when we had some length L and we took the dimension of it, we would just get a capital L. And it doesn't matter if we're measuring 5 meters, 6 feet, 2.1 nanometers, it doesn't matter at all. If I take the dimensions of any of these, it's just going to be an L, capital L. Converting units is literally just saying the same physical quantity using a different expression of that dimension. Let's say this is 5 feet long, but I also want to say that this is the same thing as 60 inches, because in 1 foot, there are 12 inches. And so even though the numbers are different, the distance or the length is exactly the same because we're measuring in different units of measurement. This is the basic idea of a conversion factor. One of the biggest things that you should know is that a conversion factor is a ratio equal to 1. For example, we know that 1 meter is equivalent to 100 centimeters. So therefore, we can write this as a ratio, and that can look 2 different ways. I can say 100 centimeters divided by 1 meter is equivalent to just 1. This is a true statement. Just like this example above with 5 feet and 60 inches, well, they're the exact same length. It's the exact same quantity. So when I divide it by each other, I'm going to get 1. I could also rewrite this as 1 meter on the top divided by 100 centimeters on the bottom. It is still equivalent to 1 because 1 meter is exactly equivalent to 100. It's like saying x divided by x. Well, they're the exact same, so therefore it's just 1. And the important part of this is that anytime you multiply by 1, you do not change the value. Only the units are going to be changing. So if you're struggling with unit conversions, all that we're doing is multiplying by 1. But it just looks different. What we're doing is that we're focusing on canceling a term to convert into another one. And here's how we are going to do that. The first step we're going to follow is that we are going to write down what you're given. Step 2, we're going to multiply by conversion factors. And step 3, we are going to cancel units algebraically. Now, when we're canceling, we want something to look like this. We're going to have some fraction multiplied by another one. And if we have centimeters that we don't want in the top, we're going to have to put centimeters in the bottom so that way they can cancel out. That's the goal. If I have a unit of feet at the bottom, I'm going to want to place the unit of feet on top so that way the both of them cancel. That's the goal. What you want to be left over with are things that don't cancel. And those are the units that we're going to be converting into. So now let's do a basic example. Here, we're going to convert 250 centimeters into meters. So we're going to start with what we know, step 1. I'm going to write 250 centimeters. It's going to be equivalent to 250 centimeters, but we're going to multiply it by 1. Oh wait, but not just a number 1. We're going to multiply it by a conversion factor. In step 2, we want to identify the relationship that's going to take us from centimeters into meters. And that relationship is the following. 1 meter is equivalent to 100 centimeters. Now remember earlier, I showed you we can write this in 2 different ways. 1 meter over 100 centimeters is equivalent to 1. We can also get the flipped version of this. 100 centimeters divided by 1 meter is still 1. And so we're going to choose the option that is going to have the centimeters in the bottom here in my conversion factor. Because you can imagine that we have our invisible 1 on the bottom in our original value. So therefore it forces the centimeters to be on the top. So if I want to cancel it, centimeters must be on the bottom and I must have meters up on top. Well, hey, I can fill in the numbers. I know 1 meter is equivalent to 100 centimeters. What that does for me is that it cancels out centimeters and centimeters, and it leaves me in a unit of meters. which is exactly what I want. So now that I've reached the goal to convert to meters, I can proceed with my next step. Now what I'm going to do is I'm going to take all the numbers in the numerator. So I'm looking at the top like this. So I'm taking 250 and I'm multiplying it by 1. And I'm going to take all the numbers on the bottom. 1 times 100. What you are doing when you're doing unit conversions is that you are paying attention to all the numbers that belong in the numerators, and you're going to multiply them together here. And then you're also taking all the numbers in the denominators, and you're going to multiply them together at the bottom. And you leave the rest of the work for your calculator. Your final answer is going to be 2.5 meters. Let's do another example. In this next example, we're going to convert 5 miles per hour to meters per second. We're first going to write out what we have. Here's one thing that you need to know how to do. We can convert mph to miles divided by hours. It's literal division. And that's what we're going to write here. It's 5 miles per 1 hour. That's what miles per hour means. That's how many miles you travel in 1 hour. And so writing it like this is going to help us see the conversions that we need in order to simplify our problem. So 5 miles per hour is going to be equivalent to, we get the same thing, 5 miles per 1 hour, but now we're going to multiply it by its conversion factor. Well, we need to establish the information we need in order to go from miles to meters and then from hours into seconds. So this problem is different in that we're converting two things at the same time. It doesn't matter which order we do it in, but we need to get both jobs done. You can either remember these, or you can just look up a table of useful conversion factors to be able to get you there. 1 mile is equivalent to 5,280 feet. Not quite the meter, but it gets us a step closer. Because when I look up some useful conversion factors, you can look it up on the internet, I can find another conversion that says, if I have 1 foot, that's equivalent to 0.305 meters. Now I have the information available to take me from miles to meters. And that's perfect. That's great. Next, I need to be sure I can get my hours into seconds. I know that 1 hour is equal to 60 minutes, and I know that 1 minute is equivalent to 60 seconds. So that gives me the pathway to go from hours into seconds. And I can do it the long way just this time, but usually I skip the 2 steps from hours to minutes and minutes to seconds, and I just use the following conversion. I just say 1 hour is equivalent to 3,600 seconds. I typically just remember this conversion instead of doing 2 separate steps, just to write less, save more time, and not have to do repeated conversions over and over again whenever I'm doing these. So let us write out our conversions. Let's begin with converting the miles into meters first. So I'm going to multiply to get rid of miles. Because I see miles on the top, I must write miles on the bottom. So by writing miles on the bottom, I'm going to force it to cancel. And this is going to allow me to convert into a new unit. Well, I know that I can go from miles into feet, and I have my conversion factor. 1 mile is 5,280 feet, and I have successfully converted from miles into feet. But that's not what I want. I want meters, so I cannot stop here. So I must multiply by another conversion factor. I don't want feet, I want meters. And so if I want to cancel out feet, I must put it on the bottom, so that way they can cancel, the units can cancel algebraically. So from feet, I'm going to go into, I have this conversion, that can get me to meters. I know that 1 foot is 0.305 meters, and I have successfully converted from miles. Now my unit of distance is in meters. So it took me 2 conversions in order to get that done, which is okay. So now that I'm good with the miles to meters, now I can focus on the hours into seconds. Notice the location of my hours. It's originally on the bottom. And I need to know that so that way I can position my conversions correctly. So because I have hours on the bottom down here, I must put hours on the top. And I know one conversion that can take me from hours into minutes. And the conversion factor is 1 hour is 60 minutes. And what that's going to do is that it's going to cancel hours with the hours on top. Do not be confused by the fact that the hours are so far away from each other. It doesn't matter, because everything is being multiplied by each other. So the order in which we multiply has no effect on the end result. So this is great. I've gone from hours, but into minutes. I need seconds. That's how I know my job is not done yet. So I'm going to multiply by another conversion factor. And because I need to cancel out my minutes now, I have minutes on bottom, I need to put it on the top. And I have a conversion that tells me how to go from minutes into seconds. So I know that 1 minute is equivalent to 60 seconds. What that's going to do for me is that it is going to cancel out minutes with minutes. And what's left over, there should be two things left over. What's left over are meters in the numerator, seconds in the denominator. And that's perfect because that's exactly what I need. Meters per second. Meters on top, seconds on bottom. That's how you know that your job is complete. Everything else is canceled out except for the units of measurement that we are looking for. Now we can proceed to the next step. So I know 5 miles for every 1 hour is going to be equivalent to. Next, we're going to do what I mentioned in the previous example. We're going to take all the numbers in the numerator. Here is 5. So I'm going to put 5.00 multiplied by the next number, 5,280, multiplied by the next number, 0.305, multiplied by the next number, 1, multiplied by the next number, 1. All the numbers in the numerator are multiplied together in the numerator, followed by all the numbers in the denominator multiplied together. Here I see 1, 1, 1. So on the bottom, I'm going to get 1 times 1 times 1 multiplied by 60 multiplied by a final 60. The rest of the job is for your calculator. And what you're going to get as a final result is 2.24 meters per second. We write it in this fashion. I sort of forgot to mention in the previous example, but we write it in this fashion because now I can say 5 miles per hour is equivalent to 2.24 meters per second. So the whole idea behind what we're doing here is that we took the original value, 5 miles per hour, and we multiplied it by 1. And here's another one, and here's another one, and here's another one. We multiplied by 1 several times. However, we did it in a strategic way such that we convert from units we don't want into units that we do. That's the entire point behind this. So my final answer is 5 miles per hour is 2.24 meters per second. Let's do one final example. Our next example reads, convert 3.5 grams per centimeter cubed into kilograms per meter cubed. Now this is a classic density conversion, and students get lost in these types of conversions because we have one, both the numerator and denominator that changes, and then second, we have a cubed that a lot of students just kind of don't know what to do next. So let's take it slow, let's take it easy. We're going to start off with what we have. The 3.5 belongs in the numerator, so I'm going to write it there. 3.5 grams per every 1 centimeter cubed equals 3.5 grams for every 1 centimeter cubed. But I'm going to multiply it by certain conversion factors that are going to take me from grams to kilograms and from centimeters cubed into meters cubed. That's the goal. Before we can continue, we need to establish the conversions that we need in order to do this right. Here's one conversion factor. I know that 1 kilogram is equivalent to 1,000 grams. Well, that's perfect. That's going to take me straight from grams to kilograms, and that completes half of the job. Now I need a conversion that's going to take me from centimeters into meters. Well, that's pretty easy to find. I know that 100 centimeters is equivalent to 1 meter. Hey, we've done that before. But here's the thing. This does not look quite the same as this. Here on the left, I see centimeters cubed. Here on the right, I see just centimeters. So here's what I have to do. I need to cube 100 centimeters, and I also need to cube 1 meter. Here's what that's going to give me. On the left-hand side, we'll do it step by step. We're going to use some exponent rules here. The power 3 gets distributed to both the 100 and the centimeters cubed, same here. The 3 to the 1 and then the 3 to the m. And here's why. Let's say we have x to the a times y to the b, and it's all raised to the c power. Well, that's equivalent to x to the AC times y to the BC. What you do is that you distribute the power to a power. So you get B times C here, and you get A times C for the base X and the base Y respectively. So that's essentially what we're doing here. But what you need to know is that the 100 here has a power 1. And then the centimeters also has a power 1. And then for the 1 meters, so it's 1 to the first power here. And then meters also has 1. Everything's raised to the first power. So if I want to simplify this, I'm going to get 1 times 3 for the 100. That's going to get me 100 cubed times centimeter cubed equals 1 cubed times meter cubed. And you can simplify this pretty quickly. 100 cubed is 1 million. So 1 million centimeters cubed is equivalent to just 1 meter cubed, 1 cubic meter. And that is the conversion factor I'm going to go ahead and use in order to simplify this problem. So let's first begin by converting grams into kilograms. Because I have grams at the top, I must cancel it by placing it on the bottom. So grams is going to go below. And I know my conversion factor from grams to kilograms. I know that 1,000 grams is going to be the same thing as 1 kilogram. That's perfect because I'm going to cancel my grams with my grams. And I'm left remaining in kilograms, which is exactly what I want. And I'm halfway there. Next, I need to cancel out this cubic centimeter. And I know exactly how to do that now. Because I have cubic centimeters on the bottom, I must put cubic centimeters on the top. And I know my conversion factor right here. I know that if I have 1 million cubic centimeters, that's going to be equivalent to 1 cubic meter. And that's perfect because I can cancel out cubic centimeters with cubic centimeters. And what do you know? What I have remaining on the numerator is kilograms. And that's exactly what I need. And what I have remaining on the denominator is meters cubed. And that's exactly what I need. That's how you know you have done your conversions correctly. Next, let's simplify our work. So 3.5 grams per cubic centimeter is equivalent to all the numbers in the numerator multiplied together. So I'm going to get 3.5 times 1 times 1 million units of kilograms on top, divided by all the numbers on the bottom. We get 1 multiplied by 1,000 multiplied by 1. And you save the rest of your work for your calculator. On the bottom, we have units of meters cubed. 3,500, and that's going to be in units of kilograms per cubic meter. And that will be our final answer. All right, so to close out for today, unit conversions are just dimensional analysis, but they're applied to units. So once you master this process, you're going to be much more confident in your physics or chemistry class down the road, where unit conversions are essentially the first step in your problem solving process. And so what you're going to find later on is that in the homework problems or the examples that you do, it's going to give you information in units that are unwanted or unusable. And your first step is going to be to go from grams to kilograms, or from yards to meters, or from feet to meters, because in physics and in science, we use the metric system. So we're always going to want to convert to metric quantities. In the next video, we're going to continue building our foundation for physics. I hope to see you in the next one.